This video is on inverse functions algebraically. We have 4 examples that we're going to be doing. These are a U-Tried. These are some of the same setup as other videos that I have. We are going to be looking at, again, quadratics, square roots, and we will have another one. The last one is going to be a rational function. So we will be looking at this one that we have not seen one like this before. So our first example, we want to, again, as always, draw a basic sketch of this. This is going to be a quadratic and it will open up. So all we know is that it will look like this. We do not know the vertex because this is in standard form, so we will not be able to find all of the information yet. The original is going to be a function because it will pass the vertical line test. The original domain will be negative infinity to positive infinity because it will go left and right. The range, because we don't know the vertex, we do not know where it's going to start from, but we do know it will go to positive infinity. So we know it's going to start at some value, but then it will go off to positive infinity. So for the inverse, we can go ahead and answer as much as we can. The inverse will not be a function because the original will not pass the horizontal line test. So this is not a function. The domain will be the original range. So we don't know everything, but we can fill in that we have a closed bracket, and then we know it's going to go to positive infinity. But we can write out the inverse's range because that will be the original domain. So we're going to write in this negative infinity to positive infinity. Now we need to actually find the inverse, because once we find the inverse, we will have it in the HK in our transformation aspect, that function, so we will be able to find the domain of the inverse, which will lead us to know the range of the original. So this f of x is going to turn to a y. I'm going to rewrite this as x is equal to 2y squared minus 8y minus 7. We need to complete the square since this is a quadratic. We're going to add 7 to the other side, so we're going to have x plus 7 is equal to. Now we have a 2 and an 8, but our a value right now is 2. We want to actually divide that out of these two values we have here. So we're going to have a 2 parentheses. We're going to have y squared left inside minus 8 divided by 2 is 4y. So actually, I'm not going to close that parenthesis yet. I'm going to take that parenthesis right here off because we're going to have to add something there. This is when we do that half of b and square it for the completing the square. So our b value is that negative 4. We're going to take half of it, so we're going to divide it by 2, and then we're going to square it. So half of b is negative 2, squared is a positive 4. So I'm going to be able to add that positive 4 to this side here. But in order for me to add it over here, I have to remember to take this value that we just have. We have to multiply it to the a value. So that becomes an 8, a positive 8. And then I can add it to this side. So what we really have, I'm just going to rewrite this as, it says x plus 7, then plus the 8 is equal to that 2 times 0 y squared minus 4y plus that 4. So that is what it ends up looking like. Now we can simplify this. So this left-hand side will become x plus 15 is equal to 2. This is a perfect square trinomial. This will factor perfectly into a perfect square. So we take the square root of the first part, which is just a y. We take the square root of the back to put it into the back, so that becomes a 2. And then the middle part, we just take the sign of it, so that's a negative, so we put minus in here. We have completed the square. Now we need to solve for the y. So the first step to solve for the y is we actually have to get this 2 off of it. So we need to divide the entire thing by 2. So we'll have x plus 15 all over 2 is now equal to that y minus 2 squared. Now we need to take the square root to get the squared off. So we take the square root of the entire thing. We'll have a plus or minus because we took the square root of this entire thing. So we'll have plus or minus square root of x plus 15 all over 2. And that'll equal to y minus 2. Now to get the y by itself, we add the 2 to the other side. So we're going to keep that plus or minus the square root of x plus 15 all over 2. So all of that is inside the radical. Then we're going to have adding 2 to the outside is equal to our y. So our inverse equation is going to be f inverse of x is equal to plus or minus the square root of x plus 15 all over 2 plus 2. We still need to find the range of the original and the domain of the inverse. Our original is not in our function notation to have our a, h, and k. We have our a, but not our h and k. Our inverse is in the format of a, h, and k. So we can actually focus on the inverse. We're missing the domain of the inverse, which comes from, so from this equation, we need the domain of this equation, which comes from the h. So inside of here, it's not going to be a 15 over 2, because what you're really doing is you are actually taking that inside. I'm going to write a little note over here. I'm just going to write this on the scrap piece. We're actually taking this x plus 15 over 2, and we set it equal to 0, so that we can figure out what that x needs to be to make this 0 on the inside, because that would be the original coordinate from the parent function. So we would multiply by 2, so that gives us the x plus 15 is equal to 2 times 0 is still just 0. Then we have to subtract the 15, so x would be equal to negative 15. That is actually our h value. H is negative 15. That 2 on the denominator did not affect anything because we had to multiply the 0 by that 2. So the domain for this equation would be that negative 15 going off to positive infinity. So therefore, since we have the inverse domain, we have the original range. So that will also be that negative 15 to positive infinity. So in this case, again, you could not find the range from the original because it was not in vertex form. But you can find the domain of this equation, the inverse, because it is in vertex form. It's in that function notation. So once we found the domain of the inverse, we automatically have the range of the original. This one took a little bit extra because you had to remember to multiply your value, your half of b squared. You had to multiply that by the a before you put it on the other side. We have to remember to do that. So even if there's a 1 there, you still multiply it by the 1, and you continue to put it over on the other side. On this next example, number 9, we have a quadratic, and it's opening up. And since we only have one letter x in here, this is also in vertex form, so we do know what our vertex is. So the sketch of this is actually starting at 0, 7, because that's our k value, and it's opening up. So it's actually going to look something like that. So our original is a function, because it passes the vertical line test. Our domain is from negative infinity to positive infinity, because it's going left and right. Our range is starting at that positive 7, because that is the vertex. This vertex is 0, 7, because again, this is in vertex form and in standard form. So our range is going from that positive 7 to that positive infinity. So we can actually answer all the inverse information. The inverse will not be a function because the original does not pass the horizontal line test. The domain will be the original range. That's going to be that 7 to positive infinity. And the range will be the negative infinity to positive infinity. So we can go and find the equation of our inverse. Going to change f of x to y. Rewrite this as an x equals a half times y squared plus 7. So to solve for y, we need to subtract the 7 over. So we'll have x minus 7 is equal to a half times y squared. Now I'm actually going to rewrite that as x minus 7 is equal to a 1/2 times y squared instead of seeing the decimal, because I can easily multiply by the fraction than I can a decimal. So now what we do is we multiply by the reciprocal of that 1/2, which is multiplied by 2 over 1, which is just technically multiplying by 2. That's really all we're doing, is multiplying by 2. So this will become a 2 parentheses x minus 7. Again, we don't actually want to distribute this because we want to keep it in the a, h, and k format so that we can easily find our a, our h, and our k. This will now equal to y squared because the 1/2 times 2 is gone. Then, to finish solving, we have to take the square root of both sides. And don't forget, the square root needs to have that plus or minus in front of it. Square root of 2 parentheses x minus 7 close parentheses is now equal to that y. So now if you look at this, we can still see that 7 in here. Our h value is attached to the x. So it's going to be x minus the h value of 7. And remember, the h goes to the domain, so the 7 is in fact the domain of this. So our answer we would write as f inverse of x is equal to plus or minus the square root of 2 parentheses x minus 7 close parentheses. Now again, you could have distributed that 2 so you don't have parentheses, but once you distribute that 2 and the parentheses go away, you no longer can see automatically what your h value will be. In this next example, we have f of x is equal to 2 times the square root of x plus 6 minus 5, where x is greater than or equal to negative 6. Again, we have a restriction because it is a square root symbol. We cannot go towards the left-hand side because anything that is smaller than negative 6, so like a negative 8, would give us a negative inside our radical, and we cannot take the square root of a negative and get a real answer. So this basic sketch, we do have our h and k because of the format it's in. The h value is a negative 6, and the k value is a negative 5, so we know it's going to be somewhere around here. And then it's a square root curve, so it'll graph something like this. The original is a function, because it passes the vertical line test. The domain is starting from that h value, which is at that negative 6. And it's going to go to that positive infinity because it's going to go right. Our range is starting at that y value of the start point, which is that negative 5. And it's going up, so it's going to be that positive infinity. So again, if this was actually going down, it would go from negative infinity to the negative 5. The inverse will be a function because this graph passes the horizontal line test. Our domain of the inverse will be that negative 5 to positive infinity. And our range will be that negative 6 to positive infinity because we have the restrictions. So we'll change the f of x to a y. And we will write this as x equals 2 times the square root of y plus 6, then minus 5. So to solve for y, I'm going to add 5 first. So we're going to have x plus 5 is equal to 2 times the square root of y plus 6. we need to divide by the 2 on everything over here. Once we divide it by 2 here, the 2 will go away, but we don't do anything inside the parentheses, inside the radical. So we're going to have x plus 5, all of that over 2, will equal to that square root of y plus 6. To get rid of the square root, we need to square both sides. So we're going to keep it as that parentheses x plus 5 over 2 squared is equal to y plus 6. Again, we don't want to rewrite this out twice and distribute because we want to keep it in the format so we can find our h and our k. Next step is to subtract the 6. So we're going to have that x plus 5 all over 2 squared minus 6 is equal to that y. So our k value is -6, so that's why our range goes from -6 up. We need to make sure that we have that restriction because the original had a restriction. We need to make sure that we still have a restriction on that range. But because the original domain had a restriction, our inverse domain also needs to have a restriction. It needs to start at that -5 because if I were to set that equal to 0, I would get x plus 5 is then equal to 0, and then subtract the 5, I get that x equals -5. Same thing for that. So we will write our inverse as f inverse of x is equal to parentheses x plus 5 all over 2 parentheses squared minus 6. Because this is a parabola, this would graph as a parabola, so you might think that the domain will be -infinity to +infinity for the inverse, but because we had an original restriction, we need to honor that restriction for the inverse as well.